Hey everyone, Krishna this side and I welcome you all to this channel. So let's solve this lead code question 2749. Minimum operations to make integer 0. Let's read the problem statement first. You are given two integers num1 and num2. In one operation, you can choose integer I in range from 0 to 60 and subtract 2 to the power of I plus num2 from num1. Return the integer denoting minimum number of operations needed to make num1 equals to 0. If it is impossible to make num1 equals to 0, we have to return -1. Okay, so we have to keep on performing this particular operation until this num1 becomes 0, and whatever the minimum operations we required to make this num1 equals to 0, that is something what we have to print into the output. In first example, when we try to see here, num1 is basically equals to 3, num2 is basically equals to -2. Okay, so if we try to pick this I as basically equals to 2 from this particular range 0 to 60, and this particular value to the power of 2 minus 2 is something what we have to subtract from this particular num1. Okay, so the answer is basically here 1. Again, when we try to pick I is basically equals to 2, again this value is something what we have to subtract from this num1 basically, and num1 was 1 from the previous operation, so here the answer is basically -1. Lastly, when we choose I is basically equals to 0, so to the power of 0 plus this num2, we have to subtract from num1. So ultimately the answer is basically equals to 0. And yes, we were able to make this num1 as 0, so we required three operations, so 3 is something what we have to print into the output. Okay, so in next example, it is not possible to make these values equals to 0, this num1 equals to 0, so we have to return -1 from here. Okay, and the constraints are basically num1 it goes all the way to 10 to the power of 9, num2 it goes all the way to 10 to the power of 9. Okay, so I guess question is pretty much clear. What we have to do, so let me pick the same example, and with this one I'll try to explain you how we can solve this one. Okay, so here I just chosen to consider the same example, and with this particular way we can solve this one, right? Like when we pick I is basically 2, so -2, that is num2, plus this to the power of 2 is something what we have to subtract from this num1. The answer is basically 1. Then next again I is basically equals to 2, so answer is -1. Lastly -1 minus this nums2 plus to the power of 0, the answer is basically equals to 0. Okay, this the same example we have already seen. Okay, so now when we carefully observe this output, right, so here we can notice that this particular num2, okay, whatever this -2 value that we have, it is going to be same for all the operations, right? So if we require here three operations, so 3 times this -2 is something what we require. Okay, so we can say that if there are k operations required, so this -2 is going to be there k times. Okay, if k operations required to make this num1 as 0, so obviously this -2 is going to be there k times. Okay, and similar this equation, that whatever this solution that we see, we can write it in this fashion. Okay, just to get some clarity, I'm just trying to make this conversion. Okay, see this one, that value that we saw here, right, it is basically from here. Okay, and again this entire value that we got it, right, -1, we can pick it from above. So same thing is something what I have written. So for this for this particular one, I have picked this value, and that is something what I have stored, and this is going to be there, and lastly this is going to be there. Okay, that is the same equation that I have written here, and ultimately this value is basically equals to 0. It is clear, right? So this way we can write this particular one. Okay, now going ahead, if I write this particular one in this one, here 3 is basically num1. Okay, 3 is basically num1, and -2 here, this -2 that we see it, right, so it is basically num2. Okay, it is basically num2. So can I write this in this way? So here this -2 basically occurred 3 times. Okay, that is num2. So let us suppose we are not clear like how many times it basically occurred, so I can write it like this way. Okay, so k into this num2. Okay, this is how I can write it. And lastly here this to the power of 2 to the power of 2 to the power of 0, this is nothing but I can write it in this way. Here it is like to the power of I1 plus to the power of I2 plus to the power of ik. K times this value is basically we can say equals to 0. Okay, this way I can write this particular solution, right? Like whatever this derivation that we saw, we can make it conversion in this fashion. Okay, now lastly I can say that this num1 minus k into this num2. Okay, it is equals to this to the power of I1. It goes all the way plus to the power of it is like ik. Okay, basically whatever the values that we can see here, it is like I1 plus I2 plus whatever the values, that power I value that we are considering, right? We can say that it is basically built with all these values that we can see it, right? This is basically built with 2. Okay, so whatever the power that we can consider to the power of any value, this entire value is basically got built with 2. Okay, it is clear, right? Like when we try to write it, how I came with this one, right? Like whatever this formula, the division and all, it was by looking into this particular one, whatever these values that we can see. It is clear that we are completely dependent on this to the power of values, whatever the values that we are seeing, and this value basically going to appear. Uh, I mean, how many times it basically appear? Like it can appear k times if we were able to make it as possibly equals to 0, right? So based on this particular one only, I was able to get this one, and lastly we can convert the entire solution in this one. Okay, so now once we got this particular one, right, like now the idea is pretty much clear. We just have to figure out this k value. If we able to get the k value, right? Okay, and successfully, if this value basically equals to this whatever this 2 power of any values that we are considering, and we are adding up. Okay, if these both the values are equal, then we can pretty much clearly say that yes, k operations basically required to make num1 as equals to 0. Okay, this clear, right? Like what I have been trying to say so far. Okay, now just let us try to figure out this k value, right? So we can try from 1 all the way to 60, like at max 60 possible values we can get it. Okay, based on the constraints and the range that we have, we can easily say that like at max 60 possible values we can get it. Okay, 60 possible operations we can get it. Okay, to make these values equals to 0, this num1 equals to 0. Okay, so what we can do is we will keep on iterating, like we will try to consider the k value as 1, k value as 2, k value as 3, and we'll keep on trying to see if whatever this value basically they are equal or not. Okay, there are also few of the things that we have to see further going ahead, but yes, so far these things are pretty much clear, right? Like what we are trying to do right over here. So the only question is like we have to figure out the k value, and once when we try to solve this one, okay, let us suppose here this num1 is basically equals to 3 minus k into here it is minus 2. So whatever the answer that we are getting it, okay, let us suppose here k directly we are pretty much clear here 3 operations we required, right? So I can say that like 3 minus k is basically 3 into minus 2 if I put it right. So here it is like 3 plus 6 is basically equals to 9. Okay, it is taking times to update. 3 plus 6 is basically equals to 9. Okay, let me take a short break. Okay, yeah. So this whatever this 9 value that we saw right here, so this 9 is basically built with these values. Okay, we can say that, right? Like because both these values are equal, and when we try to compare these two, it is basically this to the power of I plus to the power of I 2 all the way to the power of ik. These all values are nothing but binary representation of any particular number, right? When I try to convert this 9 typically, so 9 is basically represented this way, 8 and 1, right? Here it is like to the power of 0, 1, 2, and 3, correct? So this way 9 is something what we can build. So it is like 8 plus, that means like to the power of 3 plus to the power of 2 into 0 plus to the power of 1 into 0 plus to the power of 0 into 1. Here it is going to be 1. Okay, this way only this particular 9 got built, right? And this entire derivation that we saw here basically resembles to similar to this one. Okay, whatever this 9 value that we saw in binary representation. Okay, binary representation, this is the binary representation, and this value can be compared with this particular one, right? We can say easily that this whatever the binary representation of this number can be equals to this particular value. Okay, so what we have to do is we can simply count how many set bits that are there. Here the set bits are 2. Okay, that means there could be chance that with 2 operations we can make this value as 9. Like here we can say that 2 to the power of 3 plus 2 to the power of 1, it is not 1, it is 0, right? So it is 8 plus 1 is basically equals to 9. Okay, this particular value, whatever this particular value that we saw, we can write it in this way so that we can achieve 9 as an output. Okay, so we can say that like here two set bits that are there, that with the help of those 9 is the answer that we can easily achieve. But now, is it really possible that this, with the help of these two operations, we can make 9 as equal? Because here k value was basically equals to 3. With three operations, we were able to make 9 as answer and both the values are equal. Correct. With help of three operations, we got this 9 value, and this whatever the derivation that we saw here, right? It is basically equals to 9. To achieve 9, we say that here two bits basically required, but here in the output, three operations we required, right? So both the values are not matching. Here three operations required, but here with the help of two set bits, we were able to make this 9. But is it really true that with the help of this two set bits only we can make it? Again, I would say that no. Like here, with the help of this 2 to the power of 2 to the power of 2 plus 2 to the power of 0, with this one also, we can able to make this value as 9. Okay, with this also, we can able to make this value as 9. Correct? So it is again lacking. Okay. So yes, again, like if I say that if the k value is basically equals to 4 and 9 is the answer that we got it, just assume it, okay. So with this particular one, 9 is the answer that we got it. So in this 9, set bits are basically 2. Okay. But is it really necessary that with the help of two set bits only, 9 is basically can be formed? We can even consider this, right? So 2 to the power of 2 plus 2 to the power of 1 plus 2 to the power of 1 plus 2 to the power of 0. With the help of four operations, that means we can even achieve this 9. So it is clear that whatever the operations that we saw here, okay, k value that we are considering, if this k value is greater than or equals to set bit that are available in this particular 9. Okay, so in 9 set bits were 2. Okay, we can easily count that set bits using n, and whatever this n means, the value, and n minus 1. We'll keep on performing until n is basically equals to 0. So that way we'll keep on counting like how many times these values are something what we are getting it, and based on that we can easily count how many set bits that are available in this particular one. Okay, that is one way. Or even we can use there are default functions that are available, count set bits and all those things also we can easily use to count how many set bits are available in this particular number. Okay, so if the set bits that are available in this 9, if they are less than or equals to this k value, then we can say that these k operations are the minimum operations required to make this num1 equals to 0. That is the conclusion that we can derive from this one. Okay, I guess you get this idea. You can try out different possibilities. So what is this k value? How we can figure out this k value is like we will run a for loop. K is basically 1. It goes all the way to 60, and we will keep on trying to put this k value. Okay, k value in this particular formula that we generated, num1 in minus k into num2. Okay, and whatever the answer that we are getting it, we will just simply count how many set bits that are there, and if the k value is basically greater than or equals to the set bits that are available, we can easily say that yes, k operations are the minimum operations that are required to make this num1 equals to 0. Okay, because I already said that like here if set bits are basically 2, even with the help of 3 set bits, 4 set bits, we can easily make this 9 as an answer. Okay, whatever the 9 answer that we are getting it, we can easily get that. Okay, so yes, with this one we can get it. But now here the question is like, what are the false cases, right? Like how we can figure out if it is not possible, the minus one, the answer is something what we have to return it, right? That is something what we have to check how we can get it, right? So okay, let me just take again a pause and I'll clean these stuffs, and we'll discuss about that, and lastly I'll write down the code as well. Okay. Okay, let's discuss about this particular example. 11 and 5 are the values. So this is num1 and this is num2. Okay, so by considering this particular formula, same num1 minus k into 5, we will keep on trying to put this k value as 1, 2, all the way to 60, and we'll keep on trying to see if this k value is actually greater than or equals to the set bit that are available in this answer, the answer that we are getting it. Okay, here in the first one k value is 1, so when we try to put it here, the answer is basically 6. In 6 the set bits are 2. Okay, so here the k value is actually less than the set bits that are there. So it is never possible that whenever the k value is basically like in one operation, okay, in one operation this k value is basically 1, right? In first operation that we are trying to see, the answer that we are getting is here 2. So here it is like 2 to the power of 2 plus 2 to the power of 1. We cannot make these both the values equal at any point in time. Okay. So yes, 6 answer that we are getting it right. Here the values are 2 and the operation is 1. So one operations means like in a single operation that is like to the power of which value we can consider, right, to make answer as 6. It is not possible, right? So to the power of anything that we try to consider to make answer as 6, it is not possible. We have to at least consider two operations. Okay. And the k value is basically equals to 1. So this is never going to give us the answer. So k value is basically 2 is something what we have to consider going ahead. So here the answer is basically 1. Now in 1 the set bit is basically equals to 1. Okay. But the problem is the target that we got it here. The target itself is less than this k value. Like in two operations, we are trying to perform two operations right here in this one. That means like at least the value should be greater than this 2. The value that we are getting here, the k value, right? Because two set bits should be there, at least minimum two set bits should be there. That means like two operations we are trying to perform, but here the answer itself is less than this k value. Okay. So this is the false condition. That means the target that we are getting it, whatever the target that we are getting it, if it is less than this k value itself, we will simply return -1, because going ahead it is never going to give us the answer. Although this k value is actually greater than the set bits that are there, but here this target is actually less than this value. Whatever the k operations, like let us just try to assume that if 10 operations is something what we required. Okay, so far we go and we got on that like k is basically equals to 10, and the answer that we got it by performing this one is basically equals to 9. Okay, is basically equals to 9. So obviously the k value is going to be greater than or equals to this value, but just try to think that whatever the operations that we require, 10 operations, the set bit basically going to be less than this value. 10 operations less than this whatever the value that we got it, let us suppose 9. It is obviously less than this value, but this answer that we got it itself is less than this target operations. So just try to think like, is it possible even to make this to the power of 0, 1, anything values less than this k? Whatever the value that we are getting it by summing them up? It is not possible, right? So this value should be greater than this k value at any point in time to match this k greater than or equals to set bits that are there. Okay. So these are the two conditions that we have to get it, and based on that we can solve this one. Let me try to write down the code now. So let me disconnect this thing and let's try to write down the code now. Okay. So the first thing is let's define here k is basically equals to starting with 1, and we can run a while loop while k less than or equals to 60, less than or equals to 60. We'll keep on trying to generate the target. Okay. So here the answer could go large. So because these values are basically 10 to the power of 9. So by multiplying it could we can get big values. Okay. So long is something what we have to consider. So let me define here a target num1 minus again like this num2 and k is something what we are multiplying, right? So I have to consider this num2 as long. Okay, otherwise we may get integer overflow. So yes, this is something what we can do. Now this target that we got it, right? So first thing we can check is if this target itself is less than the k, like those many options that we are trying to perform. Okay, to the power of 0, 1, 2, 3, whatever the values that we are getting it itself less than this target value, then in that case we will simply return -1. Okay. If this k value is greater than or equals to long dot set, there is a particular function that is available here to count how many set bits that are there, right? So it is like bit count. That is the function that we have, and here we have to just provide the value. So here the target, in this target, how many set bits that are there, that is something what we are trying to figure out. If it is less than or equals to k, that means like it is pretty much obvious that we can even consider the k operations at any point in time. Okay, even if let us suppose two set bits that we got it, with the two set bits we are trying to generate the answer, but obviously it is possible to make it 3, 4, whatever the key operations that are there, those many times we can split that 2 and we can get the answers. Okay, so if this is the case, if it is satisfying, we will simply return the k, because the k operations are basically satisfying condition. Okay, and ultimately if nothing works, -1 is something what we can return as well. When we try to run this, okay, there is some internet issue. I think this should work perfectly fine. You can try it out. I don't know, like I had some internet issue. The moment internet is up, I'll upload this video. Okay, thank you for watching this one. Bye bye.